Good evening and welcome to video 14.1. This evening we will be looking at basic properties that distinguish acids from bases and introduce you to the first theory of what makes a substance an acid or a base. Let's begin with acids. Acids react with active metals in a single replacement reaction to form hydrogen gas. The active metals we'll talk about are those in groups 1 and 2, so the first two columns on your periodic table. For example, when Ba, barium, reacts with H2SO4 or sulfuric acid, it forms BaSO4 and H2 barium sulfate and hydrogen gas. Now, single replacement reaction means that our single compound kicks out the same charged compound or same charged element in the compound. So Ba is positive 2, so it is going to kick out the hydrogen, which is positive 1. That means Ba forms the compound and hydrogen's by itself. And remember, hydrogen has a 2 because it is one of our Hofbrinkel elements. Acids will react with bases to form salts and water. So for example, let's look at HCl plus KOH gives us KCl and H2O. So HCl is our acid, which is hydrochloric acid. KOH is our base, which is potassium hydroxide. And when they do a double replacement reaction, they form KCl, which is our salt or potassium chloride. When chemically equal amounts of acids and bases combine, we actually will neutralize the solution. So by chemically equal doesn't mean 1 gram and 1 gram. We're going to look at them being chemically equal, like their concentrations that we've been talking about. Other properties of acids are that in aqueous solutions, should you taste it, it would taste sour. Some acids will even dissociate into ions when dissolved in water, and when they do, they can conduct an electric current. And of course, we learned in the last chapter, when a compound dissociates into ions and conducts an electric current, we call it an electrolyte. Now let's take a look at bases. Aqueous solutions of bases will taste bitter. Dilute aqueous solutions will actually feel slippery. And just like acids, if they react with acids, they form salts and water. So let's look at starting with a base. So we have NaOH plus HCl gives us NaCl and H2O. So our base is NaOH, or sodium hydroxide. Our acid is HCl, hydrochloric acid, and our salt is NaCl, or sodium chloride. Again, when chemically equal amounts of acids and bases are combined, our solution is neutralized. Bases also conduct electric current when dissolved in water, because again, they will dissociate into ions when put in the water. When they do this, again, they are called electrolytes. So our first theory about what describes an acid and what describes a base. How do we determine from looking at a compound whether it's going to be an acid or a base? So our first theory is going to be the ARRHENIUS theory. So this was brought about by Svante Arrhenius, which is a Swedish chemist. So he says acids and bases must produce ions when in solution, since they can conduct an electric current. So again, they dissociate, they become these electrolytes. So an acid, when it dissolves into water, is going to increase the concentration of the hydrogen ion. So again, your acid usually begins with hydrogen, so it breaks apart. The hydrogen ion is what's going to be left. When it reacts with the water, then, it forms the hydronium ion, which is H3O+. So it's water with an added hydrogen. The hydrogen of the acid is attracted to the water molecule, which is then produces the hydronium ion. For example, when we take HNO3 and we add it to water, the nitric acid is going to break apart, so we're going to get an H plus and an NO3 minus. The H plus joins up with the water, producing H3O plus, leaving behind the NO3 minus. HCl does the same thing. We can break it up where the H comes off, combining with water, producing again the hydronium ion, our H3O plus here, leaving behind the negative ion. Arrhenius bases increase the concentration of the hydroxide ion, or the OH negative ion. So again, your ionic bases dissociate in water. When they dissociate, they break apart into the ions, leaving behind the OH. Other bases may actually react with water, removing H plus and leaving behind OH minus. Molecular bases produce OH minus when it steals H plus from water. So remember, water is H plus OH, which is why we often wrote it that way. So if you steal H, what do you leave? OH. For example, I take NaOH and it's going to break into Na plus OH minus. I guess that should be more of a superscript there to show that it's a charge. But something like NH3, which is more of a molecular base, it's going to steal from hydrogen, or steal from water, take that hydrogen, and we get still OH minus. So we're still producing the OH minus. So to be an Arrhenius acid, we must dissolve in water. And whether you're an acid or a base is based on what it produces. So remember, acids produce H3O positive, or hydronium ion. Bases produce OH minus, or the hydroxide ion.